Hi, everyone. Thank you for joining me for this talk on high-performance block storage for CloudStack. Today, we're going to be covering a topic that's quite popular nowadays in IT circles. Is storage a commodity for cloud infrastructure deployments, or is it an opportunity to differentiate? For StorPool, we believe that storage is definitely an area where having the best and the fastest and the most reliable storage can allow you to differentiate and be more competitive in the market, whereas some of the other players in our industry see it as just a commodity. You swap anything in and it will just keep working. So today we're going to go over what the next generation of IT services providers is doing, what are their goals, what are their use cases, and how we've been helping them for the last 9 or 10 years already. Then we're going to cover one of the reference customers of StorPool, a company based in the United Kingdom called Amito. We'll show you the project that they've completed with StorPool Storage and the reasons they selected us for their provider. After that, we're going to have an overview of the StorPool Storage solution for CloudStack environments. It will be a general introduction to our software and how it can help you, as well as especially if you're a service provider that matches the previous the profile in the previous two sections. So the next generation IT service provider, typically what we've seen that they're doing, what we have been helping them do, is that the typical situation is that they aim to follow modern multi-cloud infrastructure practices. So these service providers that we've been helping are doing largely automated API-driven deployments with a lot of DevOps practices being applied. Proper site reliability planning is often a topic that needs to be covered, and we help them with it. They're offering public cloud services. So this is either infrastructure as a service, platform as a service, different kinds of hosted software as a service, or cloud hosting, or they're offering private cloud services, so more tailored solutions for small and medium businesses, enterprises. Sometimes they have hosted private clouds in their own data centers, whereas other times they have managed private clouds that are managed in the location owned by the particular business that is their customer. In terms of use cases, we are seeing a lot of ONVMe deployments. So this is NVMe SSDs being used only for storage, as well as hybrid deployments where part of the cloud is with an ONVMe SSD setup. Some of the cloud is hard disks, and all of those are serving data to virtualized, container-based, or bare metal environments. The workloads that we've been managing for helping them manage rather is databases, different infrastructure types like virtual desktop infrastructure, large applications, in particular customer relationship management, enterprise resource planning apps, cloud gaming applications, and in some cases persistent Kubernetes volumes. The scale that we see in the market is about 100 terabyte plus to tens of petabytes of stored data across the whole business. And that's in typically from anywhere from 1 to 30 plus data centers around the globe being managed by a given service provider. The typical projects that they come to us with are converting legacy IT stacks to software-defined data center designs, consolidating multiple IT systems to one stack. This is the kind of stuff that we're seeing as emerging tendencies in the market. If some of this applies to you, that would be great. Please consider what questions you have as I go into the next slides, because it's important for us to understand what which of this rings a bell and which is a complete miss. So if you have any comments to this slide, please consider and share them before the end of the presentation so I can answer them in the chat. So here is the overview of our reference customer. They came to us with a very straightforward project. For a long time, storage had been the most difficult part of their IT infrastructure. So Amito came and asked us essentially, how do we replace these in-house high availability sounds based on ZFS and these different storage solutions from big name vendors? How do we replace them and install something in their place that gives us the expected results? They had the objective to have a reliable and high performance shared storage system across multiple data centers that would support a broad range of applications that is tailored to the different small and medium business customers that Amito is serving. In these deployments were across 28 data centers worldwide. So you can imagine there was a lot of complexity in the environment as we went in. The final solution that they decided to go with was CloudStack stack with KVM and StorPool Storage. That was supporting many Windows and Linux virtual machines running in the cloud on top. So why did they choose StorPool Storage for their infrastructure? It came down to three reasons. The first one being the unmatched linear scalability of the software. StorPool Storage has a distributed shared nothing architecture, meaning that there are no bottlenecks caused by centralized functions where requests are queued and processed. There are no single points of failure. In addition, StorPool is scalable. As you can see, increasing the size of the storage cluster linearly scales the performance from going from 700,000 IOPS to about 5 million on random reads, and similarly several times increase from 200,000 to 3 million as you increase the number of storage nodes and NVMe devices inside the storage system. This gave the ability to scale from anywhere from 10 terabytes per storage system to hundreds of terabytes, and grow online to petabytes of data, all with a very low latency across the whole across each storage system. Finally, the factor that is quite attractive with all this is the non-disruptive updates and upgrades to storage systems that are completely in service and with no need to bring any workloads down during the update and upgrade processes. I just want to highlight one point of this slide, and that's the end-to-end read latency. That is very important for database workloads and other types of workloads. You can see that it's StorPool Storage adds a spectacularly low amount of latency to to each read operation. About 20 microseconds is what is the execution of a read operation in the software. So that means that in a StorPool powered system, 84% of end-to-end latency is caused by the laws of physics, whereas in a similar Ceph deployment, you're going to have something like 70% of latency being purely the software added latency. The second reason they chose StorPool Storage is that we provide unbeatable performance. That was already partially visible in the previous slide, but I would like to show a little bit of how we do this. We have a very parallel architecture that achieves the maximum possible speed in two primary ways. There are multiple server services in each storage node that perform read and write operations simultaneously. And each server service works as asynchronously, resulting in many parallel operations in flight. What this results in is that the write and read operations, as they come from the compute hosts, are performed across all the drives in the storage system. And this is done together with the StorPool data fast pathing without any context switching. So as data is coming in from a virtual machine, it bypasses the kernel and the host, goes through the network and arrives at the server service where it's executed directly on the NVMe SSD. In all these cases, we are completely bypassing the kernel and avoiding these expensive context switches that would typically slow down the storage system. Together, all these technologies mean that every drive you add to a StorPool cluster increases the IOPS and the throughput for all data in the cluster. And the maximum possible performance is maintained in all the cases. You can imagine, like a drive down, server down event. We continue to benefit from these technologies no matter what happens. The third important factor for why they chose StorPool Storage is that it comes as a fully managed solution. So the full software package and set of services visible on the screen comes with every deployment. We are always helping our customers to ensure that they get the most out of the hardware that they've bought. By setting up the StorPool storage system, by testing, setting up and testing the connection to their cloud management platforms, and ensuring that after everything goes to production, they get the 24/7 enterprise grade support and that is needed to keep the system running in the best way possible over time. Finally, we also include the updates of StorPool Storage performed by our staff in the fully managed solution package, so that they essentially have an utterly hands-off solution that they simply use. Instead of having to manage the storage, they're simply users of storage, even though it's in their own data center. So what is the solution that we have for CloudStack environments that made Amito go with us? Let me go over it very briefly. StorPool Storage is a best-in-class, fully managed block storage solution. It is software-defined storage 2.0, so a very feature-rich, speedy, scalable primary storage platform. It was purpose-built by the StorPool team over the last 10 years. It has its own on-disk format, block protocol, and everything else, essentially. And it's an ideal solution for replacing storage area networks, all-flash arrays, and other storage software. With CloudStack, we have seamless integration. We are able to resolve many known challenges with CloudStack environments, and I'll give you an example in a second about a few of those. But before that, The reason we have the plugin is that it allows you to manage your CloudStack environment from a familiar UI. Essentially, each virtual machine gets one or more dedicated volumes for each of its virtual disks. So as you work from the CloudStack command line or graphical user interface, you are simply creating a virtual machine, and StorPool takes care of everything else thanks to the integration we've developed. Your environment gains from distributed storage. It inherits all the different features of the distributed storage platform underneath. So StorPool Storage has the ability to do clone provisioning, instant snapshots, thin provisioning, backup and disaster recovery, and quality of service policies can be set per virtual disk and or per virtual machine. All of that gets inherited by the cloud on top. In addition, StorPool provides overall a superior user experience, meaning that when you provision virtual machines, it's nearly instantaneous, and the data placement and other settings can be changed in flight to address changes in user requirements over time. So what does this mean for you as a service provider? I'll give you just an example here with our secondary storage bypass. Creating snapshots, creating templates, and downloading templates based on the items in the CloudStack marketplace is done directly to StorPool Storage. So all the operations are accelerated significantly. Similarly, since the snapshots and templates are created and stored in StorPool, the private and public compute node networks are used only for the user traffic. So there is no need to continuously send data from secondary storage to the primary storage. And whenever you're creating a virtual machine, whenever you're creating a snapshot, there is no unnecessary traffic back and forth between the two storage types. And finally, since StorPool creates a volume for each virtual disk of your virtual machines by cloning pre-existing snapshots, the VM, we actually are able to avoid duplication of data. And the result of that is that you can have provision to stored ratios that are anywhere from 2:1 to 6:1 provision to stored, which can be excellent for optimizing your costs for StorPool storage, as well as optimizing your overall environment, basically to ensure that you don't need so much hardware to maintain even a large deployment. So what are the deployment options for StorPool storage? First, it can be decoupled from the compute hosts. So storage is going to be on its own hosts, and it will be connected over the network to the compute hosts and the StorPool block drivers located in them. The StorPool drivers are what allows us to provide block device interfaces for each virtual disk of your virtual machines in your CloudStack environment. It's installed in each hypervisor host to ensure the connection between the StorPool storage system and the compute workloads. The other way to deploy it is in hyper-converged mode, where storage computes are running concurrently on the same hardware. In this case, you have everything running in one place, and this is also supported mode for deploying StorPool. In case you have a more complex environment, we have simultaneous multi-stack support, so you can deploy StorPool storage, partially HCI, partially decoupled. That's depending on the overall cloud architecture, and then you can connect your your StorPool storage system, or both to CloudStack, to any Kubernetes deployment that's running on top of CloudStack, or in a dedicated hardware bare metal. Or you can connect your StorPool storage system to Hyper-V or VMware and any other compute environment running in your in your infrastructure. So to summarize all of this, StorPool storage is a little bit like the holy grail of storage systems. It gives you at the same time performance, a lot of data management functionalities, and scalability. What you would typically expect from high-performance systems like sub 200 microsecond latency and high IOPS and high throughput for the whole storage system. So where you would see local SSDs, pure storage, all-flash arrays, NetApp all-flash arrays being used, that's delivered with StorPool. At the same time, you have a lot of data management functionalities where you would where you're able to get dedicated volumes for each virtual disk, end-to-end data integrity, thin provisioning, snapshots and clones, replication of snapshots. And finally, you have the scalability that is that provides you API-driven automations, scaling with standard storage drives and servers, capacity and performance pooling. That essentially you get all of these attributes in a single, well-integrated, tightly packaged solution. So you are simply the user of storage instead of the manager that keeps taking care of this quite complex part of the cloud infrastructure. So that's it. I hope it was a useful presentation that is going to open a good conversation here and maybe in the future. I look forward to your question and thank you for your attention.